All right, so earlier we found trig functions for right angles, which basically means you only have room for acute functions, which are, we only have up to 90 degrees, but we can work beyond 90 degrees if we come up with these reference angles, which kind of generalize what those angles in the first quadrant would be to what the angles in the second, third, and fourth quadrant would be. So it's going to look something like this. It all travels our way back to a reference angle. So if we have an angle theta in standard position, so let's sketch out what that would look like. So we've got angle theta, remember that's our initial side. So theta could be anywhere. I mean, we can put it just about anywhere in those three quadrants that we want. So this big angle all the way, this would be bigger than 180 degrees. That would be our angle in standard position. And so it looks like this. What we do is we choose a point somewhere on that terminal side. Let's call that point P. And point P is going to have some sort of XY coordinate. And what we do is we essentially turn this into a right triangle right here, and we do the sort of SOHCAHTOA stuff based on that angle. All right, so it's going to look something like that. This is going to turn into a right angle, and so we essentially treat that as being the right triangle that we use. The issue is, depending on where we are in different quadrants, our X and Y coordinates are either going to be negative or positive, where in the first quadrant they were always positive. We were used to these triangles all having positive side lengths. But this, we don't treat this as a side length, we treat it as the Y value or the X value, which could be negative. So here's kind of a revised version of what our SOHCAHTOA would be. So this, we've got our X and Y coordinates. We call this measurement R, so that's just this distance from the origin until whatever this point is that we choose. So instead of using opposite, adjacent, and hypotenuse, we're going to use X, Y, and R. So these are our 6 trig functions. Whoops. So we've got sine of this angle right here. Sine is going to be the Y coordinate over R, which is still kind of like the opposite over the hypotenuse, even though y could now be negative. So that's the big difference. And then very similarly with cosine, if we're looking at the angle here, we use the x coordinate over the hypotenuse, which would be x over r. So again, similar to like adjacent over hypotenuse, but this time x could be negative depending on where we are. And then tangent is going to be the y coordinate over the x coordinate. Similar to opposite over adjacent, but I could have negative values. And then remember, these three just pair up with them and they're just the reciprocals. So this would be r over y instead. Secant is the reciprocal of cosine, so that would be r over x. And then cotangent is the reciprocal of tangent, so that would be x over y. Okay, so those 6 trig functions, so this could be anything, because before we could just do somewhere between 0 and 90, now we can do any angle that we want. Okay, so here's how we normally set these up. We're going to look at an example, something like this. So you set up where your terminal side is and what the point on the terminal side is. So with these problems, I'm going to give you this point, and you'll be left to set it up. So let's make ourselves a little sketch. So we've got a terminal point at 8, 15. So let's scale this by 2. All right, so it'll be somewhere down there. So you draw your terminal side. It's going to look something like that. There's your initial side. This whole thing right here is your big angle. So that's going to be somewhere between 270 degrees and 360 degrees. So it's a big angle. We want to find exact values of the 6 trig functions. So here's what we do. So this measurement is 8, negative 15. What we need to do is we need to find this measurement right here. So we do that using essentially a distance formula. So to find r is going to be the square root of this distance right here. So between x coordinates is just the difference between 8 and 0. So that's just 8 squared plus, and then here we want the difference between 0 and negative 15. So that would be 15 squared. All right, so simplify all that up, and I'm just going to plug the 8 squared is 64 plus 15 squared. That gives me 289. So I have the square root of 289, which, let me see if that comes out evenly. Yes, it does. It comes out to be exactly 17. All right, so r is 17. So here's what we know. We've got x is 8, y is negative 15, and r is 17. So we can just plug into these values right here. So sine is the y coordinate over r. So the y coordinate would be negative 15 over r, which is 17. Cosine is the x coordinate divided by r. So the x coordinate is 8. Divided by 17. And then for tangent, I have the y coordinate divided by the x coordinate. So negative 15 divided by positive 8. So for the other three, you just flip them. So these ones you have to kind of figure out on your own, and then you just know what the reciprocals are, and you just flip them. So instead of negative 15 over 17, we'll have negative 17 over 15 for cosecant. For secant, we just flip this to be 17 over 8. And for cotangent, we flip this to be negative 8 over 15 instead of negative 15 over 8. So that's the first one. Second one is really, really similar, except this one is going to be weird because one of our coordinates is 0. So you'll see how that makes this one a little bit different. So we set this up. We've got 0, negative 2, so that is going to be right here. So we've got this, and then my terminal side is going to be right here. So my angle goes all the way to there. So I have my x coordinate, I have my y coordinate. This one for r equals big square root. So the difference between 0 and 0 for my x coordinate would just be 0 squared. And the difference between 0 and negative 2 would be 2 squared. So this is just going to come out to be a nice, neat 2. I have the square root of 4, which is just 2. So x is 0, y is negative 2, and now r is 2. So I'm just going to plug in those same values. So sine is the y coordinate over r, which reduces down to negative 1. Cosine is the x coordinate over r, which reduces down to just a 0. Tangent is the y coordinate over the x coordinate, and when I divide by 0, that means that it is undefined. Okay, so the tangent for this one is undefined. So that's the first thing we hit that's a little bit unusual. Next set, we just take the reciprocals. So we've got cosecant. So the reciprocal of negative 1 is still negative 1. Here we have the secant. So the secant, if I flip this, I have 2 over 0, and dividing by 0 is also going to be undefined. So here the secant, sorry, that was supposed to be a u. Secant is undefined as well. And my cotangent is the reciprocal of this, so 0 over negative 2, so that actually is just 0. So here I have two of my things that are undefined. Remember, if you try to take the reciprocal of 0, it's going to be undefined. So these two are defined, but with the other pairs, you have one that's undefined and one that's equal to 0. Okay, so that's your first one. Those are trig functions if you're going somewhere beyond the 0 to 90 degree range. Now let's look at these reference angles, because what's going to end up happening is, say you look at something that's in the second quadrant, it's going to have an identical angle back in the first quadrant. Or if you're looking at something in the fourth quadrant, it's going to have an identical angle back in the first quadrant. So rather than kind of learning the rules 4 times over, you just learn what happens in the first quadrant, and then you'll be able to very easily transfer it into what's happening in the second or the third or the fourth quadrant. All right, so let's look at these reference angles right here. So we're going to compare quadrant 1 to quadrants 2, 3, and 4. Okay, so we've got 4 quadrants. So let's say in quadrant 1, we have just like a nice normal angle like this. So there. And we're going to sketch out just little similar pictures. So quadrant 2 would be something like that. Quadrant 3 would wrap all the way down here. And quadrant 4 would wrap all the way back here. So starting here, it would wrap all the way around, and that would be an angle in quadrant 4. Okay, so and you can draw wherever you want in those quadrants, just so we have something for reference. So here, theta just is theta. And so we just use normal theta, same way that we did in all the 12-1 stuff. Here, what we do is we take theta, and so if we look at the reference between 180, this measurement right here is always going to be 180 minus whatever theta is in the first quadrant. So if we compare this, we're going to call this theta prime. Okay, so that's going to be that little difference between 180 and where our angle is here. So what we do is we say that theta prime is always going to be 180 minus whatever theta is. Okay, so this right here, so if this was 150, this would be 30, because that's just 180 minus 30. So this would be the reference angle. Okay, so our reference angle is what we consider to be theta prime. All right, so now here, this one, we're going to use this little guy as our reference angle. We're going to call that theta prime. So here, theta prime is theta minus 180. We're going in the other direction. Okay, so like this whole angle minus 180 would leave you with this little reference angle in here. And then finally in the fourth quadrant, we're going to treat this little piece as our reference angle. And so that would be the difference between going all the way around. So theta prime there would be 360 minus theta. Throw the degrees on here. All right, so we're going to use that while we move on to the next page and do some of our reference angle stuff. All right, so sketch each angle and then find its reference angle. So 330 degrees is somewhere between 270 and 360. So it would be like right there. So going all the way around, that would be 330 degrees. And so when we talk about its reference angle, we want this little guy right here to be the reference angle. So remember from the previous page, when we're in the fourth quadrant means we do 360 minus theta, and that gives you your reference angle. So here our reference angle would be 30 degrees. So whatever the sine, cosine, and tangent are for 30 degrees, we're going to use that as our reference angle for 330. Okay, we can do something really similar for this. Negative 5 pi over 6. Okay, so let's flip really quickly back to this. So this is where 5 pi over 6 is. So since we're not really familiar with radians yet, it's good to reference back to this. So if I go from here and go, instead of going forward 5 pi over 6, I could go backwards to 5 pi over 6 right there. Okay, so it would land me right in that spot. Okay, so that'll be right here. So starting here and then going backwards, that is negative 5 pi over 6. So it lands me in the third quadrant, and in the third quadrant I use this little guy right here as my reference angle. So I was supposed to do my reference angle minus 180 degrees, but instead I'm going to do my reference angle minus pi, because remember pi and 180 are exactly the same. So this guy right here ended up landing in the same spot as 7 pi over 6, so I'm just going to refer to it as 7 pi over 6. 7 pi over 6 minus pi. So this, just to get a common denominator, we can think of this as 6 pi over 6. So my reference angle, if I subtract those, is going to be pi over 6. So just knowing that chart that we have on the previous page is going to help us to find those reference angles. Okay, so now last thing we're going to do, knowing those reference angles, we're going to be able to find sine, cosine, and tangent for any angle that's in the second or third or fourth quadrant. All right, so it's going to go something like this. Step 1, find the measure of the reference angle. Okay, so you either want the sine or cosine or tangent of the reference angle. All right, and then step 2, we're going to determine the sine of what the trig value should be. So determine whether it's positive or negative depending on what quadrant you're in. And then finally, you basically, for step 3, just attach the sine to the trig value. Okay, so here's how that's going to look. Let's look at example 4 here. If we want to find the sine of 135 degrees, first thing we have to do is we have to figure out what that reference angle is. So 135 degrees is right here. So this right here is the 135. We want to find the reference angle. Reference angle is going to be this measurement right here. Okay, so we do 180 minus 135. So this is 45 degrees. So step 1, if we want the sine of 135, first thing we're going to do is find the sine of the reference angle. So sine of the reference angle. We just find it on our handy little chart here. Sine of 45 degrees is root 2 over 2. Okay, next thing, sine of the trig value. Okay, so sine of 135, we want to figure out if it should be positive or negative. Okay, so sine is the y-coordinate divided by the r-coordinate. So when I'm in this quadrant right here, my y value is going to be something that's positive because I'm in the second quadrant. And my r value is always going to be positive because that's just a distance. So I know that this is going to come out to be positive. All right, so then for number 3, I just attach the sine to the trig value. So I know that the sine of 135 is going to be positive root 2 over 2. It's like that. Okay, so let's do something really similar for this one. So the cotangent of 7 pi over 3. So first of all, it's probably easiest to think of this in terms of degrees rather than radians. So if you want, you can always feel free to just convert these things into degrees. So remember what you do is you multiply by 180 over pi in order to convert it into degrees. So what will happen is the pi's will cancel, and then we can divide these both by 3, and we end up with this. So this gives us 420. All right, so let's figure out where 420 would be. So 420, we actually go all the way around. That's 360. And then that leaves us with, we've got 360, leaves us with 60 more degrees to go. So we go 60 more degrees, and that would land us probably right about there. All right, so our reference angle for 420 degrees would be 60 degrees. So what we do, we first find the cotangent, whatever we're finding. I guess I should throw the other 3 in here. We find the cotangent of the reference angle. So first we find the cotangent of 60 degrees. So cotangent of 60 degrees is root 3 over 3. And then we figure out what this sine should be. All right, so the sine, so your cotangent is the x-coordinate divided by the y-coordinate. So I'm in the first quadrant. So if I had a point right here, my x-coordinate would be positive, my y-coordinate would be positive. That would make the cotangent positive. So remember, your last step is just to attach the value to the sine. So it's just positive root 3 over 3. So something like that. So we're going to be doing a lot more practice with this throughout the course of the chapter. So believe me, it will start to feel a whole lot easier.